So good morning everyone, and let us start this lecture. I think this is lecture number 5. What we are doing in lecture number 4? The last lecture
Thermal expansion.
we were doing thermal expansion, correct? And I think we had solved a problem. Is that correct?
Yes.
The problem in which the
Linear
difference
expansion,
in the
linear
length should
expansion.
remain same, right?
Yes. Linear
Okay.
expansion, aerial expansion,
Let
volume
us.
expansion.
Yes, beta.
Linear expansion, aerial expansion, volume expansion.
Okay, and we had solved one problem. Okay. We begin today's class with an example only so that we can refresh ourselves as to what we are supposed to do. So we will be now starting with an example, and let us do this one, and let us see if you can solve this one. I think this is problem number 7 in the sheet. I will make sure that I call up the office again, and I hope you get those sheets. Now remember, whatever questions come, they have to be done with the knowledge that I've already given you. There is not even a single word of knowledge that I can give you now. The only thing is the question language can be a bit different at times, and you'll have to understand the language of the question and have faith that you know how to solve this. Let us look at this question and see. Remember, JEE Mains is all about time. You only get one chance to read the question. If you are reading the same question twice, you are utilizing the time of the next question in the first question. So read the question once, slowly first, then you try to speed up your reading so that in one reading you can understand the question, and I'll help you out in doing that by underlining the important points of the question so that you don't miss anything. We have an So let us start with the question. I'll underline the important points, and I hope that we can understand the question in one reading. An iron rod whose length is 50 centimeters is joined at an end to an aluminium rod whose length is 100 centimeter. Now, instead of giving you the lengths, they could have said one has a length L1, the other one has a length L2. Same thing. L1 and L2 becomes more easy because we get the answer in terms of alphabets. All measurements refer at 20 degrees Celsius, so that is your T1 or T, whatever you call it. The coefficient of linear expansion of iron and aluminium are this and this. As you can see, aluminium has got more expansion. That means it will expand more. Iron will expand less. So if I will make this question, I will write this question as this. I will write the length of one rod as L1. So I'll just write it. I will write the length of this rod as L1. I will write the length of this rod as L2. I will write the temperature as T, or let us not take T, let us take it as theta. I will write it as alpha 1 and I will write it as alpha 2. And the question is very simple. What is the average coefficient for the composite system? When I say the composite system, it consists of the entire rod, which is made up of two rods. That is the question. Read it once. In one reading, you should be able to understand the question. I'll give you a minute to solve this in terms of L1, L2, theta, alpha 1, alpha 2, or in terms of whatever you wish. Try to solve it and give me the average coefficient of the composite system. Your time starts now. So how do I do about it? First of all, let me find the initial length. Initial length, let me call it as L0. What is L0 equal to? L1 plus L2. Yes or no? Yes or no?
Yes, sir.
Okay. Now, what else is given to you? You have to, you are given alpha 1 and alpha 2. From alpha 1 and alpha 2, I can find out the length of L1 dash. What is L1 dash? The new length of the iron rod. So that will be equal to
Alpha L1. delta t theta.
L1 into 1
Delta
plus alpha 1 into delta theta. Is it correct? Yes or no?
sir. Yes, sir.
Okay. Here delta theta is not known. The initial temperature is given as 20 degrees and I think they have missed. Sometimes there is a question where they've missed. The final temperature I think is 100 degrees. So change in temperature becomes 80 degrees. I will call it as delta theta. Is it clear to everyone?
Yes, sir.
Then I find the value of L2 dash. L2 dash is the final length of the second rod, and that will be equal to L2 into 1 plus alpha 2 into delta theta. Then I find the change in length of the system. The change in length of the system will be equal to new L minus the previous L. What is the new L? New L will be this length plus this length, and I subtract the original length. At the end of the day, if I hold my ear like this or I hold my ear like this, the change in length will be equal to how much? That is what you said in the previous case. It will be equal to L1 alpha 1
Delta t
delta theta
theta.
plus L2 alpha 2 delta theta. Yes or no? So you
Yes,
do
sir.
it this way or you do it that way, you end up at the same case. Yes or no?
Yes, sir.
Once you get the value of delta L, you can find the coefficient of expansion. You already know the theory behind it. Delta theta, see? So this delta L divided by L into delta theta would give you your alpha. Now, the beauty of this question is this 100 degrees Celsius is not required because delta theta is getting cancelled from everyone, from everywhere. Do you see this or not?
Yes, sir.
So you see, they have done this question so long, they have done so many calculations, but if you would have listened to me and done all the calculation at the end, you would not have to do a lot of calculation because delta theta actually gets cancelled. What is the final answer that you get? What is the final answer that you get in terms of L1, L2, alpha 1, alpha 2? What is the final answer that you get? What is average alpha equal to? Can you have the answer? Can I have the answer? Anyone has the answer? The final answer. No one has the answer? Shall I give the answer?
20 into 10 to the power minus 6.
No, that is not the answer that I was looking for. The answer that I was looking for is L1 alpha 1 plus L2 alpha 2 divided by L1 plus L2. That would be the final answer that you get. Is it clear? Without doing all these complex calculation, this is what you will end up with. Am I clear?
Sir.
So, the moral of the story is don't do calculations in between. The better way to do any question is instead of using its values, write it as alpha 1, L1, L2, x1, x2, whatever. Get the answer in terms of this. And at this stage, when you get the answer, at this stage, the final stage, you put the values, get your answer, and you stay happy. Everyone understood this question? Have you noted down this question in terms of L1, L2, alpha 1, alpha 2? And you have solved it, yes or no?
Sir.
Okay. Then let us solve this one, and I hope you can solve this one. I can enhance it as well. So I'll just make it bigger. Yep, this looks better. I have a bigger view. Again, read the question once. In one reading, you should be able to understand the question, and then you will have simply need to solve it. A brass rod and a lead rod, each of 80 centimeter. If I would have to make this question, I will write this length as L. At 0 degrees Celsius, I will write this as θ1. Are clamped together at one end and their free ends coinciding. Oops, clamped together at one end and free end coinciding. That is what you need to imagine. Clamped at one end, free ends are coinciding. The separation of the free ends of the rod if the system is placed in a steam bath. Steam bath means the final temperature is 100 degrees Celsius. I hope you understand this. Yes or no? Yes or no? So I can call this as θ2. This θ2 is actually 100. This θ1 is actually 0 degrees Celsius. Length is given as L. Alpha brass can be called as alpha1. Alpha lead can be called as alpha2. As you can see, lead will expand more and brass will expand less. What will be the difference in the separation of the free ends? Can I have your answers? Fast. And I'm not looking for numerical answers. Even algebraic answers are good enough, because getting the numerical answer from the algebraic part is a simple maths from 4th to 5th standard, multiplication, division, that you should be able to do it. Okay. I'll give you a minute to think about it. Not more than a minute. Anyone has any answer? Are you there? Everyone in the class?
L into alpha 1 minus alpha 2 into 10 to the into delta T.
Yes, you can get that answer. L1 into alpha 1 minus alpha 2 into delta theta. That would be your answer. They found out the length of this rod, they found out the length of that rod. Doesn't matter. You ultimately subtract it. If the lengths were different, then what would have been the answer? If this one was L1 and the other one was L2, what was the answer then?
L1 alpha 1 minus L2 alpha 2.
No. No. First of all,
Delta L1 minus delta L2.
yes, obviously you can do it differently. You have to delta L1 minus delta 2. The difference in the free ends, they are asking the separation of the free ends. So you understand the question. See, as if I change a simple thing in the question does not change. The question remains same. You just have to change your understanding of the question. Now, just to make things simple, I don't want to complicate things. The blue one is L1. The blue one is L1 with alpha 1. As you can see, L1 and alpha 1 are smaller than L2 and alpha 2. Do you understand this? That the length of the first rod and the coefficient of expansion of the first rod are taken as smaller compared to L2 and alpha 2. L2 is also more and alpha 2 is also more. You understand the difference between the two?
Yes, sir.
Yes. Now you
L1
have to
alpha 1
find.
minus L2 alpha 2, L2 alpha 2 minus L1 alpha 1 into delta theta.
Yes. So the final answer will be L2 minus L1 plus L2 alpha 2 minus L1 alpha 1. Do we understand this?
Yes, sir.
That into delta theta, obviously. That would be the answer in this particular case. Okay. So try to understand the question and then try to make some sense for this question. Now, there are one or two more questions in the sheet, and I will give you those questions for homework. I hope you get this sheet, or let us solve this question as well. Let's see. Um, you might not get this question in mains. You might get this question in advance because it might take some solving. So let us do this. Might not be for maths, but might not be for mains, but for advanced. Now again, the node diagram is given, so that takes another minute for you to understand it. Let us try to understand the question in one reading and mark the important points. Two rods of length L2 and coefficient of expansion alpha 2 are connected freely to a third rod of length L1 of coefficient of linear expansion alpha 1 to find and to form an isosceles triangle. So two sides are same and the other side is different. The arrangement is supported on the knife edge at the midpoint of L1, third rod, which is horizontal. The apex of the isosceles triangle is to remain at a constant distance from the knife edge. What is the condition for that? The time starts now. You only have one chance to read the question, remember. Any idea how you're going to do this?
So we are trying.
One more minute. Did you get the answer? Now,
No, sir.
what is the answer?
We didn't get, sir.
You did not get the answer? Not a problem. It's not a difficult problem. Just give me a minute. I'll give you a minute.
Sir, explain, sir. Sir, explain, sir. Sir, explain, sir.
So how are you supposed to do this? It's pretty damn simple. You just need to find out the initial length. You need to find out the final length, and they must be equal because it should not change. Now what they are looking for from this point D, if you can see this point D to this point C, the distance DC before and after, before heating, after heating must remain same. Do we understand this?
Yes, sir.
But that's it. Once you understand this, the question is completely solved, as you can see on your screen in bigger sense. How do you find out the length? In the first case, this is the case before heating. Do you understand how I have found out the length of this part DC? Right angle triangle? Yes or no?
Yes, sir.
Hypotenuse square L2 square minus L1 by L2, L1 by 2 square. That is the length before. Afterwards, if you heat it by temperature delta theta or T or whatever, the length L2 becomes L2 into 1 plus alpha delta theta. You square it minus L by 2 into 1 plus alpha delta alpha 1 and alpha 2 squared. Now, what is the condition that this distance remains fixed? That both these should be same, yes or no?
Yes, sir.
So once I hope you have noted equation number 1 and equation number 2.
Yes, sir.
That's it. Then you equate equation number 1 with equation number 2. This is equation number 1, L2 square minus L1 by 2 whole square. This is equation number 2. And after this,
Yeah.
in fact, before this also, physics has finished. Now this is all maths. So on the left hand side, I have this. On the right hand side, I have this.
Chamagaya, sir. Chamagaya.
We have neglected the higher terms and we end up with this. Where were you stuck? Now remember, whenever in this chapter you have alpha and you have raised this to the power anything, you will have to use something known as binomial theorem. You understand this binomial theorem? Because alpha is very, very small. So whenever you have 1 plus alpha raised to the power something, 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 you will have to use the binomial theorem. And that's it. Anywhere in this question, you might see such questions in your slit wala experiments where the distance of the slit is very small. You have to use binomial expansion. Use binomial expansion and you are done. Okay, got this?
Yes, sir.
Chalo then. That takes us to the next set of questions, and the next set of question is pretty damn simple. This is example number 9. Can you tell me what is the answer for this one? And you will have similar questions coming many times in JEE. So this is question number 9. It's pretty damn simple. You have a rectangular plate which has a circular cavity as shown in the figure. I hope you can see that in the figure. If we increase the temperature, then which dimension will increase? We are given dimension A, you are given dimension B, you are given dimension C, and you are given dimension D. Which all dimension will increase?
All will increase, sir.
All will increase. So basically, The radius of the circle will increase, the length of that thing will increase A, the breadth of that thing will increase B, and the distance between that edge and this will increase because it is going to expand. We understand this? Simple question based on basic concept. You will have lot of these questions coming your way. Now, let us go on to one more question on linear expansion. Now, before we go on to any question in linear expansion, as I told you, you might find a question where your alpha. See, we had seen this equation dl is alpha L naught d theta, or d, here they have used dt. In most of the books you see dt, but I will use it always as delta theta because t is standing for time. In conduction we use t for time. So delta L or dl is alpha L naught d theta. Do you understand this? From here we had arrived to this, we have got this equation and we have understood this equation, yes or no?
Sir.
Now, sometimes you might, not in JEE Mains, in JEE Advanced, I have not seen such a question, but such question can be easily made, where you have this alpha, which is normally treated as a constant. You may have this alpha varying. You may have a varying alpha. Now, if you have a varying alpha, it can vary either with temperature. So normally it varies with temperature, but we neglect that point. So it can vary with temperature, or it can vary with the distance of the rod. You can obviously make a theoretical question where alpha varies on the rod. Now, in that case, how you will find out the total expansion of any rod? If alpha varies with distance, you can write alpha as some linear ax plus b. In that case, the total expansion delta L, because dl is alpha L naught delta theta, d theta, alpha is varying. You can find out the total expansion in this fashion. Do you understand how I got this equation?
Yes, sir.
Please note this down. So this is how you can get the value of total expansion when alpha varies with distance. For example, if I would have given you alpha is 2x plus 3, alpha is 2x plus 3, length of the rod is L, and the temperature is changed by delta theta. Can you now give me what is the total change in length of this rod? Give you 1 minute to solve it.
Square plus 3x.
Yes, you got the answer?
I'm integrating, sir.
So this question may not come in JEE Mains, more in JEE Advanced. It can also come in JEE Mains. Nothing such. It does not require so much of time, so it can also come there. It's all about time, nothing else. What is the change in length of the rod? Length, original length is given as L. What is the answer? Got the answer? Shall I help you?
L square plus 3L into delta theta.
Yes, what?
L square plus 3L into delta theta.
L square plus 3L into delta theta. I just need to integrate it. So this will be the integration of 2x plus 3 dx, and this delta theta is a constant, so it will just jump out of the integral. X has to be integrated from 0 to L, so your final answer will be L square plus 3L into delta theta multiplied by L. Do we understand this?
Yes, sir.
It is as simple as that. I think here in this they are missing the term L, correct? So just write the term L, total expansion. It has to be multiplied by L. It has to be multiplied by L. Yes, it has to be multiplied by. Okay. Do you get this point?
Sir.
Everyone got this? Okay. On similar lines, you can have an alpha which is varying with temperature, which is the more likely case that alpha, since it varies with temperature, it can vary with temperature. So I can have an alpha which can be written like this: 2t plus 2 plus 3 again. Alpha varies with temperature, or I should write theta, 2 times theta plus 3. Now the length of the rod is L and the temperature is changed by delta theta. Or instead of writing it as delta theta because it might create some confusion, I will write it as the temperature is changed by theta. Temperature is changed by theta. Can you now find out? Can you now find out the change in length of this rod?
Theta square plus 3 theta into L.
So you can just integrate it and you will get your answer. That's it. And again, insisting on the uh, same point that all expansion is a 3D, three-dimensional expansion. We are just taking it as 1D or 2D because the other dimensions are very small for a thin wire. Only one dimension is significant. The other two dimensions are small. For a thin sheet, only two dimensions are bigger and the other third dimension is very small. Now the next type of question that you might encounter in this chapter, which may also involve your error and measurement wala chapter and percentage error and percentage change, or this, all these questions are very important and they can come anytime. So just need to solve one of those. What is the percentage change in length? And they can ask you what is the error in the measurement and all those. So error, measurement, and everything. Yeah, we can include such questions here. Of a 1 meter iron rod, if the temperature changes by, again, I will write the length as L, I will write change in temperature as delta theta, and I will write the coefficient as alpha. What is the percentage change in length? And the answer is
Delta L by L into 100.
so it is simply equal to alpha delta theta multiplied by 100. That would be the percentage change in length. Okay, this finishes that. Now, since we are in linear expansion, we are, first of all, the heading is expansion of solids. In expansion of solids, we are in linear expansion, and we are trying to solve problems on linear expansion. What we have done till now is solve general problems in linear expansion. Now, from now onwards, what we are going to do is we are going to do a case by case study. So what are the places where you will find this utility of this linear expansion? What type of different sets of question that you can have? The first set of question that we have already seen is general question based on you just find out the change in length from various different ways, or percentage change in length from various different ways. Now, there can be different sets of questions, so we'll also understand the use of linear expansion, and we will do it under different headings. The first heading or the first series of questions here will be the thermal stress. Have you heard about this word thermal stress? Have you heard about the word thermal stress?
Yes, sir.
What is thermal stress? Okay, this comes from a chapter. I mean, thermal word is from this chapter, but stress comes from the chapter properties of matter, where we have studied about stress and strain. What do you mean by stress or strain? Have you heard about that stress strain diagram?
Force by area. Force is equal, stress is equal to force by area.
That is the fifth
Force
standard
acting on
definition.
any cross section area.
That is the fifth standard definition of stress. That might not work here. Okay.
Tangential force acting on a unit cross section area.
Tangential force acting. Have you heard about Hooke's law or that stress strain diagram? Okay, this is the body. How do I produce stress in this body? Try to make it simple. How do I produce stress in this body? How do I produce stress? How do I stress something? This is a body that I have. Any body. This is a body that I have. How do I produce stress in this body? Don't give me the definition of stress because the definition that you are telling me is also wrong. Force divided by area. Force divided by area is also pressure. Stress and pressure, see, in some terms, yes. To define it, you have not understood what is stress. You just understood force by area, stress. No, force by area is not stress. That's the way you find out the stress. You have not understood what is stress. What is stress? How do you stress a body? Any thoughts on this? For example, if I have this body and if I just apply one force here, does the body get stressed? No, the body may not get stressed. There might be some deformation, but it might not get stressed. How do I then produce a stress? The best way to produce a stress is to press it from both sides. Now the body will be under some stress. If I stretch it like this, then the body will be under some stress. Now stress can be of different types. We have seen. Can you name some stress? Thermal stress is there, but longitudinal stress, tangential stress. Have you heard about this? Modulus of rigidity, Young's modulus, bulk modulus. Heard about those terms? Heard about Young's modulus, bulk modulus, modulus of rigidity, longitudinal stress, tangential stress, volume stress. Heard about those things? No?
No idea, sir.
No idea? Okay, not a problem. You might you're not read the chapter properties of matter, where you have stress, Hooke's law, stress strain diagram. You're not gone through this chapter. That is not there in your course, beta. Okay, leave it. Let us first understand the example. Have you heard the word strain? Have you heard the word strain?
Heard, sir.
You have not heard the word strain?
Heard.
You have heard the word. What is strain? No idea. Okay, let me not waste any time and let me make things simple. If I apply two opposite forces on a body, what happens? I will try to elongate or change the shape or change the size of a body. Remember, there was a chapter known as Newton's laws of motion. When I was applying force on a body, the body was moving, and we were thinking that the body is not deforming, the body is not changing its shape or size or orientation. The body is just moving. In this chapter, no, not in this chapter, in the chapter on properties of matter, which was also based on elasticity, because when we were pushing it, when we were putting stress, it was getting deformed, but when we were taking out that stress, the body was coming back to its original position. The such bodies are known as elastic bodies. You remember elastic bodies?
Remember.
Yes, okay. Now, when you put an external force on the body, and that is how you understand stress. When you put an external force on the body, it moves or not, that is a different question, whether it moves or not. That is not my criteria. Whenever I put a force on a body, the body gets strained. Now, when I say strained, that means there is a change in its size, there might be a change in its shape, there might be a change in its orientation. Whenever an external force is applied on a body, the body gets strained, the body changes. Now, as soon as the body changes, now remember the word, as soon as the body is strained, so first of all, I apply an external force. That external force does not create a stress. Do we understand this? Do we understand this? Do we understand this?
Yes, sir. Yes.
Please keep on, because I don't see you, so I don't know whether you're understanding it or not. It's good to understand the meaning. So when you apply a force on a body, the body does not get stressed. The body does not get stressed. When you apply force on a body, the body gets strained. The body gets strained. It changes its size, shape, or orientation, or length, or breadth, or area, whatever, or volume. As soon as strain develops in a body, the body will try to come back to its original position. The atoms, the molecules, they get separated from each other, so they have a tendency to come back to their original position, because that is the position of greatest stability. So they will try to come back to their original position. They will exert forces on each other. Those forces are known as restoring forces. Have you heard the term restoring forces? Simple harmonic motion, restoring forces. So they will develop. So restoring forces are developed inside this body. This restoring forces measured per unit area is known as stress. Do you understand what is stress now? Whenever a body gets deformed, the body is strained. The body will try to come back to its original position. Restoring forces are developed inside the body. These restoring forces per unit area is known as stress. Now, if the body is elastic in nature, these restoring forces, F restoring, these restoring forces are equal to the external forces that are applied, then only the body will come back. And therefore, we call this stress that is developed inside the body, which is actually equal to the restoring forces per unit area. In case of elastic body, and elastic bodies only, you can call them as external forces per unit area. I hope you are understanding the meaning of the term stress.
Sir.
First, you get strained, and then you get stressed. Strain is the cause. Stress is the effect, not the other way around. All of us understand it other way. First, the body is stressed, then the body is strained. No, 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 no. First, the body is strained, then the body gets stressed. And therefore, we have not strain by S diagram. We have stress by strain diagram. Do you remember this diagram? Here there is stress and here there is strain. Strain is the cause, stress is the effect. Got it? Some people say that this diagram is ulta. Strain should be there and stress should be here. No, the diagram is either your dimag is ulta. Okay, so this is stress. In short, longitudinal stress will change the length. Tangential stress will change the shape. Volume stress, pressure, will change the size, not changing the shape. It will change the size. A ball inside water is getting equal pressure from all sides. The size changes, shape remains same. In tangential stress, shape changes. In volume stress, shape remains same. That is all about stress that you need to know. Now, what about thermal stress? If a body of a rod is free to expand, it can expand. If I have this rod, if I heat it, it expands. If it expands, there is no stress, because it is getting expanded. There will be no thermal stress. There will be no thermal stress, and there will be no thermal strain. Strain, if I say strain is longitudinal strain, is defined like this: change in length divided by original length. In fact, strain is change in dimension divided by original dimension. Do you know what is strain? Strain is normally denoted by I sometimes denote it by epsilon. Epsilon is strain. Strain is change in dimension divided by original dimension. So if it is length, change in length divided by length. If it is breadth, change in breadth divided by breadth. If it is area, for God's sake matter, change in area divided by area. If it is shape, change in shape divided by original shape. If it is volume, change in volume divided by original volume. Do you understand this?
Yes, sir.
Strain. So if the rod is free to move, free to expand, there is no thermal stress. Thermal stress I'm talking about, not the original stress. Original stress is always there. Whenever you apply force on a body, the body gets strained always. And stress comes. Stress and strain is produced only when an object is restricted or to expand or contract. So if I have this rod, of length L, and if I heat it up, I just kept it here and I heat it up, will it have any thermal stress coming inside it? Will there be any thermal stress produced in a rod like this, which I just kept? No, there will not be any thermal stress. Now, if I clamp it from this end, I've clamped this rod from one end. Now I heat this rod. Now the same question comes. Will there be a thermal stress in the rod? Will there be a strain in the rod? Yes or no?
Sir.
Yes or no?
Yes.
No. It can still expand. This end is free. It can still expand. There will not be any thermal stress or thermal strain. Do we understand this?
Yes, sir.
But now if I clamp it from the other end also, now I have a problem. Houston, we have a problem. If I clamp it from both ends, now if I increase the temperature, will the rod have strain and stress?
Yes.
Now it will have strain and stress because I'm not allowing it to expand. Now the next question is, what type of stress would be there? You must have heard about two types of longitudinal stress, tensile stress and compressive stress. Have you heard about these terms? Tensile stress. Tensile stress is trying to stretch, right? And compressive stress is trying to bring it closer. Yes or no? We understand this?
Yes, sir.
The question again comes back to you. I have a rod which is fixed at both ends, and I increase the temperature. The first question is, does the rod have stress? Yes or no?
Yes, sir.
The next question is, what type of stress? Tensile or compressive? These are the questions that will come to you in the examination hall that test your understanding of the topic.
Compressive.
Why compressive?
Because two ends are fixed.
Because it is fixed, that's why it's compressive, right? The logic is right, but the answer is wrong. It is tensile stress. Amazed? Yes or no?
Yes, sir.
Why you're amazed? The answer is tensile. Correct answer is tensile. Now you have to understand what is happening here. Why compressive? What do you think is compressive? See, it is being compressed already by the clamps that you see. Do you understand this? It is already compressed by those clamps. It is trying to expand. But the best way to understand this is, it is trying to expand in length, but it is not allowed to expand in its length. And therefore, the stress in this is not tensile, but it has to be compressive. That is correct. I was trying to confuse you. The stress is compressive. So basically, the way to remember this is, if the temperature increases, the stress that is developed is compressive. If the temperature decreases, if I would have cooled it down, then what would have happened? If I cool it down, then what will happen? What type of stress is developed inside this? If it is heated, it is compressive, correct. If it is cooled down, then
Tensile.
okay. How do you understand this? Because if it is cooling down, it will try to contract, but it is not allowed to contract because it is being now extended, and hence the stress is tensile in that case. So remember, it is opposite. When it's heated, the stress is compressive. When it is cooled down, that stress is tensile. Now, how do you find out that stress? First of all, you have to find out the value of strain. How do you get the value of strain? Change in length divided by original length. If you do change in length divided by original length, you will have alpha into delta theta. So that will be your delta L by L. Delta L by L is your strain. Your strain is denoted by the letter epsilon, and that will be equal to alpha into delta theta. I hope you understand till that. But the name of the topic is thermal stress. How do you find out stress? Sigma. How will you find out the stress? Sigma. Remember, stress by strain is Young's modulus. Yes or no? Longitudinal stress by longitudinal strain is Young's modulus. Do we understand this?
Yes, sir.
So how will you find out the value of stress? Stress will be equal to strain multiplied by Young's modulus. So your thermal stress would be coming like this. It would be equal to Y alpha into delta theta. That would be your thermal stress. Am I clear with this concept? Such questions have come for thermal stress, and they can easily come even in JEE Main or JEE Advanced. Do we understand this, everyone?
Yes, sir.
Okay. Now, once you find out the thermal stress, they might also ask you to find out the value of, they might be also asking you to find the value of the force developed in the rod. How much force is developed in the rod? Now, to find out the force developed in this rod, they will give you the area of cross section of this rod as A. The rod will be clamped like this. They would give you the area of the rod. From this area of the rod, you can find out the force which is applied on this rod, and the force applied on this rod will be sigma stress multiplied by area, and that will be equal to Y A alpha delta theta. Do we understand this?
Yes, sir.
Now, normally what do? I put a negative sign before this force. Why do I put this negative sign before this force? Just to make you understand. Normally, the tensile force, if I call the force as tensile force is taken as positive, and compressive force is taken as negative. That is the convention that we use just to denote their direction. Tensile is positive and compressive is negative. So I put this negative sign to make you understand that when temperature increases, the force is compressive. Wait, when the temperature decreases, the force is tensile. Do we understand this?
Yes, sir.
Okay, so this is all about thermal stress that you should understand and you should remember. Now a couple of questions on this and we are done with this topic. Just a couple of questions because this is just one simple formula for thermal stress. For strain, if you do one or two questions, you should be good enough. This is example number 12. In the given figure, the rod is free at one end. I think I gave you this example. And the other end is fixed. When we change the temperature of the rod by delta theta, what will be the strain produced in the rod? What will be the strain produced in the rod?
0.
0. No strain because it is free to expand. So there is no strain. We move ahead. Tan, tan, tan. So example number 15. Again, I have already sent you this sheet. I hope you get it and you should be able to solve the other question. They are simple. Read the question once. I will underline the important points. Get me the answer. Steel rod is clamped at its two ends. So we have a simple question and rest on a base. The rod is in a natural length, so I'll call this length as L0 or L. Find the longitudinal strain developed in the rod is temperature rises to 50 degrees. I'll call it delta theta. Coefficient of expansion, I will call it as alpha. What is the strain produced in the rod? And the answer is pretty simple. How much is the strain produced in the rod? Then to make the question more what should I lengthy or what, I will give you the Young's modulus of this is y. What is, and the area of cross section of this rod is A. What is the force developed in this rod and what type of force is developed? Can I have the answers, please? Yes, beta.
Force is equals to Young's modulus into area into alpha into delta theta.
That is the stress. No, that is the force. That is force or stress?
Force.
Force is y into A into alpha into delta theta. What type of force would be there? Would it be compressive force or would it be tensile force?
Compressive.
See, the strain is compressive. Strain is compressive, so the stress is also compressive. Do you understand this? Can I have some raise hand that you understand this?
Yes, sir.
Okay, great. Now similar question could be asked in a different way, and this is example number 16. If you do 3 or 4 examples on this is much more than enough. You don't need to do anything. That again, simple question. It has got some numerical values. You just need to multiply, divide, add and subtract. A steel wire of cross-sectional area, a cross-section area is given as A, is held between two fixed support. If the wire is just stout that this is the initial temperature theta 1. Determine the tension when the temperature falls to 0 degrees. So this is theta 2. So the temperature is decreased. What type of stress or strain will be developed? Coefficient of expansion is alpha. Young's modulus is y. What type of stress or strain is developed? It is cool down.
Tensile.
See, the answer is here. Tensile, the strain is tensile and the tensile force is given by this formula. You put the values, you get the answer and you stay happy. Am I clear with this topic on thermal stress?
Yes, sir.
Okay. That just finishes one part of the linear expansion. In the next class, there are many more things. What I'll do is I will try to cover it up in the next class. I will not do 2 or 3 examples on each type because once I do one example, the other example follow. Do you understand this? If I do one example, the other example follow suit?
Yes, sir.
Yes or no? So what I'll do is we'll go to a heading and then we'll do just one problem. If I find some different problem, I might do it. If I don't find any different problem, we will just go ahead with 1 or 2 problems and then we will wind off this linear expansion, maybe the expansion of solids by the next class. So that's it from my end for today. I hope you love this class. See you tomorrow. We'll be going ahead with the topics. I'll find out if you got the sheet or not, and I'll find out why you do not get it. Okay. Chalo then. Take care. Have a nice day. Enjoy your life. Bye bye.